We do not recycle a large majority of our electronics. So it goes in landfills somewhere. Only for an alien civilization to come on Earth a billion years from now and look, oh, look, these were two-dimensional people. They had everything in two dimension. We don't think about these things, particularly when it comes to electronics. But as we are collecting more and more data and sensors, we need to start thinking about these things. Not that we can do anything, let's be honest. If our immediate market gives us money, we will still take it. You know, the company which paid highest in my campus placement was a company called ITC. What does it do? What does ITC do? Tobacco, makes cigarettes. And you all were happy to take a job in it. Paid the highest. So we have got that marketing dilemma to be worried about as well. Good. So we decided on megapixels. Our next problem is this. We can only do 2D chips. So everything has to be in 2 dimension. Rest these are research topics. We can have 3D stacked chips. The only 3D stacked chips which are in market very successfully are the memory, because they are same kind of chips. You have one memory, another memory, another memory, and you can stack them all. Different type of chips coming together has been very tricky. Research-wise, yes, but it's very tricky to make in market. So most of the stuff which is in the market is a 2D chip. So everything has to sit next to one another. Now the human brain doesn't do that. I mean, do you know what's inside in human ear? It has layers of canals, small bones, big bones. In the human eye, we have lens, we have aqueous filter, the liquid, then there's a retina. Behind that retina, you have different cells, and then you have got a rope wire going in. So the nature had the 3D advantage. We don't. So you have to do everything in 2D. Good. I'm already coming to 12:16. I was hoping to break it shortly. So let's see what we will do in the next few days. We will be learning, well, as I said, there is no necessary a book to give to you to learn. I hope I will be able to write that good book when I get some time and rest. So we'll be learning primarily from papers. This is more of a thing you use IEEE Explore for getting papers. Most of you would have free access to it. Most of you still end up using Google or Google Scholar. Not the best source of knowledge. Generally speaking, Google is not the best source of knowledge, but one of the reasons why I figured out Google Scholar is not a good source of knowledge is one of my own papers was heavily plagiarized by somebody. They changed everything except the list of authors. So they took the entire paper of ours, changed the name of authors. So my name disappeared and all of my colleagues' names disappeared, and their name came in there. So mine was a paper in IEEE Transaction. This paper was in some international journal of singing and dancing. Google somehow figured out that was more important than my paper. So when you search for that topic, it comes before the original freaking paper. And this is why it's the only half decent good source of knowledge. Okay? Now most of you would have started reading papers. We'll be giving you loads of papers to read, and you'll have a day to read and come back the same day. We'll also see if we can do a mini project here. So the mini project challenge this time would be to make the best pixel possible. I will teach you how to design a pixel, and when you are in the laboratory, we will try to make it as small as possible. The smaller the pixel, more megapixel you can keep it in phone. Not because of technology, because of the market. Okay? Good. This next brings us to the next question. Most of you who are doing PhD and masters would have had the unfortunate realities of reading a paper, and you would have read a whole paper, spent an afternoon only to figure out it was completely useless. Some of those who are smiling have gone through this experience. Those who are not smiling are like, this guy is useless. If the paper has been peer reviewed, it should be highly useful, right? So this is my way of reading a research paper. I'm telling right in the beginning so that when we do this, you can understand, and do the same with my papers. Read the introduction. See if it makes sense. If it makes sense, don't read the next section. Go straight to the conclusion. See if it still makes sense. These two make sense, then possibly you can read the next section of the paper. If your introduction doesn't make sense, look at the references cited in the introduction and see if they make better sense than this paper. Okay. And if they don't make better sense, then life is not worth exploring this further. Stop reading it. Because you can spend the whole evening and you'll still not be able to do this thing. Then after introduction and conclusion has made sense, go to the next section, which is generally the theoretical background. And this is where you will have loads of equations. Now let's be honest. As engineers, we don't like equations. We all thought we were good in maths because entrance exam likhe the, right? And we know the limits of any calculus operation immediately. We remembered all those NEET and what's the exam called? Is this called NEET these days or JEE or what's the fancy name? JEE, right? So because you have written the entrance examinations, you know you are good in maths. Let's be honest, you are not. Okay? We know how to solve a mathematical problem. We don't appreciate maths as much in our schooling system. And same with physics. So my trick is, do not read that theoretical background section. Read the methodology and experimentation section, because here you will understand a bit of what has been done and what is the result of it. I skip all the maths in the first time I'm reading a paper. Okay? You can come back. If everything else makes sense, come back to the maths and then try to ascertain maths. Because somehow we have this magical understanding within ourselves. If we can write an equation to look very complex, we are good scientists. And what is a scientist who doesn't give a complex equation? I mean, Einstein was hopeless. He only gave E is equal to mc square. What's the equation with 3 terms? Agreed? So those of you who had the misfortune of reading research papers, you would have seen fancy looking long equation. Can anybody tell me what does that equation do? And this is from a meme which ran around when I was a PhD student. All of you in JEE exam, how much money did you guys give to get in? See, that's the kind of abuse I used to get. And now you guys are not even finding it funny. So Muralidhar sir, you are going to get 5 complaints from this batch. So you are going to be in trouble, not me. All the maths are wondering. Yes. Do you think both sides are 0? 2 is, so this side is 2. Somebody did the limit. Said they were the JEE exam preparation, right? That limit I will know it's equals to 2. What's on the left hand side? Sin square x plus cos square x is 1. What's that log limit? So this side is 2, that is 1, so that has to be 1, right? So the equation basically says you 1 plus 1 is equal to 2. Looks really cool. Unfortunately, in science world, we do end up doing these mistakes. And it's not a mistake, it's just we understand this equation by ourselves because we have spent a lot of time developing that equation. And we forget that our end user does not have that much time to understand that equation. He or she only sees that equation for a second or 2. And most of us who are not mathematically well trained, some of us are, don't get me wrong, there are some engineers who are very good in maths. But a good majority of us, we are good in solving problems. So you will see such equations appearing quite frequently in research literature, even if it's top journals. And hands-on, I have also done this. Some of my papers will have fancy equations which I can explain in much better fashion. So that's why I ignore all the maths in the beginning. Okay? In generally speaking, for use IEEE for electrical engineering, ACM for more computer background, most computer science colleagues will also put their AI-based papers on archive. Try to read full journal papers. In electrical engineering, we also publish conference papers, which are the smaller versions, and generally they don't contain all of it. But mind you, the word proceedings of IEEE is not a conference, it's a full journal. That's the most important one. But proceedings of IEEE conference on XYZ, that may not be carrying everything which you need. Maybe still be a very good paper. And there are some decent science journals like Science and Nature, which has occasionally papers published from our community. They're primarily linked to biology. Look, I mean, a brand new phone is not as interesting as found the bacteria which is going to kill all of us. So the bacteria which is going to kill all of us gets published in Nature, brand new phone, well, we make money. Okay. So this is what we are going to do. We are also going to do a bit of artificial intelligence. I will at least spend a day on, not on neural networks as a whole. That will be a different course taught in a different department, but how to make these. Because I said we are going to make head. So in head, we are going to do the sensor design. We're also going to do the hardware design of the neural network, the brain. We still don't know how the brain works. Because if we knew, we would have made one. I sat in a very interesting talk on, I was working on psychophysics. There was doing few faux pas I have done as a researcher. We all do, right? Early researcher, we are bright with our energy. So I was working on cameras. And of course, I thought, human eye is a good camera. So if I go to a biology department and understand how the human eye works, I'll come back and make the best camera in the world. So I took a year break in my PhD. I got a scholarship to go to any institute in Europe. So I went up in Max Planck Institute of Brain Research. So how long biology can be? I mean, we always thought we are better than people who are preparing for medical entrance exam. Let's be honest, engineers are better than everyone else, right? Everyone is a yes, yes, yes. That's a good line we all can agree to. So how hard can it be? And people who study the human eye as psychologists, medical doctors, it can't be that hard. I went for 1 year fellowship to study human eye. First 3 months, I realized these guys who have been working on human eye for 200 years don't even know how this signal converts from light to the electrical signal here. Forget about what's happening in the brain. We still do not have pure understanding of how this how a billion pixel goes into 11,000 signals is an unknown thing for us. So mimicking the human brain is tricky. Mimicking the human eye is also tricky. The other interesting thing which happened was there was a guy from IBM. IBM used to have a big project called, I think it was called Deep Blue. They were making a big, powerful machine which will mimic the human brain. And this gentleman who came and talked to us about the memory stack structure of this big machine. They were talking about DRAMs. And the idea was like we are going to mimic the human brain memory. A very senior psychology professor who has worked his entire life on human memory raised his hand and said this thing. You have figured out how the memory works. Shit, 40 years of my research gone down the hill. Please take over my professorship. I am going to retirement. What's the use of working on human memory anymore? So thing remains, we do not understand. What we do know is what does it do? We don't know how does it do. So if we can somehow get similar information or similar result as the human brain do, we will be happy. Things, we know it looks at, when we look at this image. So do you know what I'm looking while I'm looking at you guys? What my brain keeps on going to? There's a gentleman who's flicking his pen. Nothing wrong with it, continue working on it. But that's a motion. So rest of all you are still, like, a cobra snake waiting to bite me. So things which are still does not enter our brain immediately. Things which are moving they cause immediate action. Okay, do this experiment. Let's do it. So look straight to me. Raise your hand on one side. And then don't worry, I'm not going to make you do RSS salute or Hitler salute for that matter. Just move it sideways. And you will see as it starts, no, this way, this motion. As it starts coming favor. So here, I don't see this motion happening as well. Here, I don't see my hand, but I feel something is moving. And as I go forward, I of course see things. So our lateral vision, so we have got two. We have got a central vision system where I can see everything. Sideways, I only see motion. I do not see exactly what's happening. To some reason, I see that we grew up in the forest. And I believe in theory of evolution. I don't know where your religious background is right now. But let's assume it to be correct. Well, it is a theory, so it has to be correct. When we're evolving in a forest, we have to be worried about moving things. Moving things are bad. Snake moves, lion moves, tiger moves. Still things, not so bad. So our eyes or brain is trained to look at motion first. And then it's, let's see what is. So we know we can see motion very quickly. So as something which you would like to do in our imaging system also is to look at motion. Something has happened, or a sound, something has changed. So if I speak in monotonous voice, the same sound, that's the quickest way to put you to sleep. I can still put you to sleep. Professors have got this unique ability of mothers singing lullaby and professors teaching a lecture. These are the two things which put people quickest to sleep, right? So the reason why it does it, we get a constant same frequency, same tone. So unless you go up and down, take pauses or do things, life becomes tricky. The other thing is that we only have a constant span of time. So how long can you concentrate on something for? I'm waiting for somebody who will say, I do pranayam every day in the morning, and I can concentrate for 2 hours. 5 seconds. That's a classic master student, isn't it? 5 seconds and see which other campus company is coming this time. So there is a thumb rule which says the number of minutes we can concentrate is equal to our number of years we have lived. And it saturates at around 22, 23. So as we grow up, a 2-year child has a 2-minute concentration span. A 3-year child has 3, and so on and so forth. Around 22, 23, we saturate and we stay till there for the rest of our lives, slowly growing or increasing. And after a while, of course, we start falling down. So you cannot concentrate on a lecture for more than 22 minutes, even if you are assuming you are terribly good students. So one of the reasons which you would have seen, every few seconds I break the speed of lecturing. I go and talk about something more silly, which is often more fun than engineering. So we need to find something which at least works for 22 minutes non-stop. Okay? And this raises the next question. So if we get time, I will talk about history of engineering someday. If we get time and we get bored of sensing. I'm also thinking of writing a book on history of humanity. And engineers should never write history books because we hated history in our school. Agreed? There are few things we all engineers can agree on. History was, and I'm kind of hoping no historian will ever see the recorded lecture of a Gyan course. The first 5 minutes would have bored him or her to death. The reason why we don't like history is because it teaches about wars, kings, queens, which year what happened, who gives a damn to what year what happened. I think that's the wrong way of looking at history. And as an engineer, of course, I will say historians don't know what the hell they are talking about. We, of course, know better than that. But the way I look at history is, history of humanity is actually history of engineering. At this point, you might think I love my own field too much. But if you get time, I'll prove it to you. That kings, queens, battles, they are always very local. If you're looking at globally, the important epochs in our history were things like invention of wheel, invention of fire, the ability to throw a turnpike upwards, ability to make guns quickly. These are the things which were epochs of our history. So I'm looking at history from an engineering perspective. And if I get time, we will do that as well. But for the time being, let's do a history of AI in one slide. So my take on AI is humans started thinking many, many years ago. And then we thought, can somebody else do our job? The job which frightened us the most was multiplication. Addition, subtraction, multiplication, division. And that's why we came up with different computing machines. Starting with abacus all the way till computer. Same with communications, right? We are essentially asking a machine to do our job. And now we are thinking, can somebody else do the thinking for us? And that's the artificial intelligence for you. We'll stop for the first part of the lecture. It has been an hour of talking. I will take a break every hour because you can't concentrate for 22 minutes. I can't talk for more than 20 an hour, and I forgot to bring my water bottle. I did have my water bottle somewhere, but I dropped it somewhere else. Okay? So, are there any questions on what we are going to do? At this point, you might say, sir, you taught absolutely nothing. How the hell we will have question on absolutely nothing? Yeah. Somebody has a question on absolutely nothing. Well done. Amplify your voice. I can't hear. Yes. Oh, thank you, sir. Of course it is different. They're two different things. I said you need 3.2 megapixel for printing. For printing on a postcard size picture, if you look at how many pixels are needed to fool the human eye. Look, we print as dots. Okay? If we print A, we just make dots of A. So if you really magnify it, there is gap between these dots. So to fool the human eye, we need that many megapixels. In the same way, to fool the human eye when it comes to video, I said I will come to video at some point of time. How many frames do we need per second? 24, even 20 is enough for most human beings. Right? So if you take 20 still images, it fools the human being. But that's not the whole, I mean, we are missing motion in between the scenes. There are applications where we make 100,000 frames per second camera. If you're looking at high reactions, or if you're looking at something moving very fast to you. Okay? Most of these are export controlled cameras because they go on special things. But you are losing information there. So what I meant to say was, if you're printing, that will fool the human eye in thinking that it's a continuous image. If you keep on zooming it, of course, there'll be a difference in resolution, but not on your screen. If in your screen the image quality is different, there's more to a camera than just resolution. And the more part will be, इंतजार कीजिए, the movie is still coming. There are things like how do we, because essentially we are converting light to a voltage. How are we converting there? What's our noise limit? All the other electrical things which we hate will come in picture. Signal amplification, noise filtering, data conversion, ADC, DACs. Okay? So all of this leads to say how good the image quality is. Which is also a saying, megapixel alone were not enough. Does our customer know about that? Well, you guys don't know about this, and you are electrical engineering masters or electronics engineers masters. Okay? There was a time when one of the Taiwanese company, they cut down on the image number of pixels, and still their image quality improved. But market didn't like it. Okay? Any other questions? So you have had an hour of multiple speeches about how cool this place is. An hour of me talking about how everything else is hopeless. In the second half, we will start looking at the first sensor which we are going to play with. The sensor which we are going to spend most time would be the cameras or image sensors, as we call them. We don't use the words cameras, we use image sensors here. Not because they are, well, they are the coolest. I did my PhD on them, and my chair is called Chair of Image Sensors. Because they're also one of the most successful in market of all other cam sensing technology. And there is the audio sensors as well, but they haven't changed dramatically. And do people still use landline phones? No, but those who use, I mean, okay, think of it this way. The sound quality in normal mobile phone calls can still become very bad. But image quality we have learned to improve if we have decent resolution. So because these sensors have been fairly market successful, they are fairly mature as well, and they were the first to integrate. They're also the first sensor we started working on as humans. What's the first thing we did as humans? What's the background? We used to paint things on caves. So it's our natural tendency to record our own history. That's why we take pictures. It's not that we like ourselves. Okay, most of us like ourselves as well. But think of it this way, taking your own picture versus taking picture of Rajnikant, whose will you take? Oh, sorry, it's Andhra, right? So Nagarjuna, or who is the superhero these days? Who is the you guys don't watch Telugu movies anymore? Pawan Kalyan. Okay, this is later to my generation. Do they still do the, how many of you are from Warangal, from this institution? Do they still do movie nights here, or they have forgotten that thing? And you still have to watch a Telugu movie every third week? Sorry? So in our generation, we used to have Hindi followed by English followed by Telugu. And that was the ragging I used to do to my students. They had to translate the Telugu movie live to me. And trust me, it's a heavy ragging because, let's be honest, most Telugu movies have romantic scenes in them. Ask a 17-year-old to translate that in English. Brilliant. So what's the law of ragging? When can you be punished? After you have done the ragging? So 25 years down, maybe I will not go to jail anymore. So bottom line remains, we like taking our own pictures, irrespective of how good we look. We like recording our own history, either through, and most of it in the past was through images. We started painting things. So I'll go through images of, most of us think things like selfie is a modern innovation. We have been making self-portraits throughout the history of humanity. Most painters who are famous also painted themselves somewhere. So we'll go through this in the second half. It's 12:42. I will call a break now, unless there are any other questions on what to do. How many of you have used the software Cadence before? One person, which means he can teach the rest of you. Right? Okay, then I will do an introductory session on Cadence before moving. So if you want to do a camera pixel, camera chip, we would like to do work on Cadence. And then I will have to go and figure out how many of you are actually registered here and how many of you are here just listening to me talking about everything else. Okay, dokie. Thank you very much. We'll see you at what time, sir? What time after lunch we meet? 2:30? Meet at 2:30? Okay. Good. It's Saturday today, isn't it? So ideal electronics professor teaches on Saturdays and Sundays. See you around.